Hey everyone, in this review video we are going to look at calculations involving light. We're not going to get into any of the theory about electromagnetic waves and photons and all of that. We're just going to look at some of the mechanics of plugging values into the light equations. Okay, there's two main equations you need to know. The first one is that there's some symbols you need to know. Let's go over the symbols first. So the first one is that this is a Greek letter nu, and this is going to stand for frequency. The usual unit for this is 1/seconds, or what we call hertz. Sometimes in physics you'll hear that called cycles per second, but think of it as how many waves are passing by per second, right? And then the other important symbol is this guy. This is the Greek letter lambda. All right, that's not the best lambda ever, but okay. And that's going to stand for wavelength, all right? And usually that's going to be in meters. The equations that relate frequency and wavelength, and actually these, I've run out of room already, so I'm going to grab these and move them over. So there's an equation that relates these two to each other. The first one is that the frequency for light is equal to the speed of light over the wavelength, and so that's the first one. That kind of makes sense because if you have a large wavelength, if they're all moving at the same speed, longer wavelengths, longer distance between peaks means your frequency is going to be shorter. Those peaks are going to pass you less frequently if there's a long distance between the peaks. And then the other equation involves the energy of a photon, and there's two forms of that. There's the frequency form, and there is the wavelength form. Which really all you're doing is taking this equation up here and plugging it in to this one to get the second one, but it's okay to think of it as two separate equations for now. That you do need to know these values of the constants h, which is known as Planck's constant, or Planck. It's just harder to say that way. Planck's constant is 6.626 times 10 minus 34 joule seconds, and c, the speed of light, is 3.00 times 10 to the 8th meters per second. And those are the, we're in general chemistry, we're not dwelling on where these equations come from and how we derive Planck's constant, all that. Those come up in later classes, and we'll deal with those then. And as much as it's cool, it's difficult for a physical chemist like me to skip over those things. We're just going to kind of take those as that's the way it is and not worry too much about it. Okay? All right. So let's do some practice problems. All right. So the first problem is, what is the frequency of a photon of light with a wavelength of 532 nanometers? Now, the equation we're going to use here is that the frequency is equal to the speed of light over the wavelength. All right. By the way, just to quickly point this out, you can, if I had done this, we're going to solve for the frequency here. If I had given you the frequency and solved for the wavelength, it's pretty easy, because what you do is you multiply both sides by the wavelength. That cancels out. Then you get wavelength times frequency equals speed of light. And then you solve for wavelength. And wavelength equals speed of light over frequency. So in both cases, wavelength over here and frequency over here are on opposite sides of the equal sign, and one's the numerator and one's the denominator. Okay, so if you're ever like sitting here on a quiz and you're like, oh, I can't remember how to do the algebra here, you just switch the position of the frequency and the wavelength. You just flip-flop them, and that's a handy math trick that always works. If that bothers you, you can always think of it as cross multiplication and just solve. Okay, anyway, we've got to get this wavelength into meters first before we can plug it in. So we're going to do a unit conversion here. We know that there's 1 times 10 to the 9th nanometers in a meter, and if you don't know this yet, now's a good time to get that down, because we are going to use that quite a bit. So Hundreds of nanometers is like visible light, so we tend to use those a lot in these practice problems. Anyway, you plug this through, and that's 5.32 times 10 to the minus 7 meters. And now we're going to plug in frequency equals speed of light over wavelength. So the speed of light is 3.00 times 10 to the 8th meters per second. Our wavelength here is 5.32 times 10 to the minus 7 meters. And so now we're going to plug that in to our calculators. You got to be careful here because you do have here what am I trying to say? Scientific notation. Everybody's calculator is a little different. The way that I prefer you do this is that, for example, you enter in your calculator, you enter this as 3.00, and then you find a button on your calculator that either is a capital E or sometimes it's a double capital E, but it shows up as a single E on the calculator. I don't always understand that. Anyway, and then 8. This here means 3 times 10 to the 8th power. And then you don't have to deal with parentheses and all the times and carets and everything. However, you can do it however you want on your calculator as long as you know how to do it on your calculator, all right? And I would really urge you to take some time and make sure that you are confident about how to make that happen on your calculator, okay? Like I said, they're all a little different, so just take the time to do that, okay? All right, so anyway, and I've erased it on my calculator, so I'm going to just double check because I don't want to get this wrong. I'm struggling with my calculator today. And that's going to be 5.64 times 10 to the minus 14. Okay, that's what or positive 14. Sorry, y'all. And then now the units is the next question. So meters canceled with meters. In the numerator, you're left with 1 over seconds here, right? 1 over seconds is the same thing as hertz. So I'm going to leave that as hertz. You could write that as 1 over seconds, and I don't know about everybody else, but I'm perfectly comfortable with that. So, all right, there we go. All right, so that's the frequency and wavelength relationship. The other one, let's look at an energy example. What's the energy of a photon that has a frequency of 102 kilohertz? So here, there's 2 energy equations. This one, that's you can't tell. And this one, and we picked the one to use based on whether we're given frequency or wavelength. You could change frequency into wavelength and vice versa, but this happens enough that it's worth using separate equations. So anyway, so we're going to use this one because that's the one that has frequency in it. Remember, if it's kilohertz, that's frequency, Greek letter nu. Please don't call this a V. That drives me crazy. It's a nu. Just get with the Greek alphabet. Okay. All right. So now we're going to, we've got to change that into hertz to plug in. So 102 kilohertz. And if you can do this in your head, that's awesome. But if you can't, this is great too. Remember, it's just like kilometers to meters, right? 1 kilohertz is 1,000 hertz. So that's going to be 102,000 hertz that we're going to plug in. So the energy here is going to, and I'm going to flip into scientific notation because it's easier to deal with. 10 to the 5th hertz times, I plugged the hertz in first, times Planck's constant, 6.626 times 10 to the minus 34 joules times seconds. Here, it helps to think of the hertz as 1 over seconds to look at the units, because you have 1 over seconds here, and you have seconds here, so seconds and 1 over seconds cancel, and you're left with joules, which is the unit of energy, so that seems appropriate, right? So then you go to your calculator, 1.02 times 10 to the 5th times 6.626 times 10 to the minus 34. And that's, I did it again. I hit the Okay, I'm just going to do this one in my head. This is this is close enough to 6.63 times 10 to the minus 29. Okay, right? Yeah, okay. And then that's in joules. Okay. Incidentally, this is a radio, like, when you turn the car radio on and you turn it to 102 FM, this is a car radio frequency, or any radio. It's just, I only listen to the radio in my car anymore. That's a radio frequency, and they tend to be pretty low energy. It's part of the reason that they're not bad for you. Okay, and we broadcast them all over the place. Cool. So that's the energy equation. So what I'm going to do here is I'm going to give you a practice problem that I'd like you to pause the video and work the problem, and then so get out a piece of paper, work the problem, and then restart the video, and I'll show you the solution. All right, so hopefully you've had a chance to work the problem. So we're asking to find the frequency and the energy of, it should say of a photon of light with a wavelength of 9.50 centimeters, okay? So we got a wavelength of 9.50 centimeters. Let's just jump that into meters just to make our lives a little easier. So that's going to be 0.0950 meters. All right. So we got to find the frequency. So frequency is speed of light over wavelength. Speed of light is 3.00 times 10 to the 8th meters per second over 0.0950 meters. Meters cancel. We're left with 1 over seconds, also known as hertz. And that's going to give us 3.16 times 10 to the 9th hertz. Okay. All right. So then we're also asked to find the energy. So the energy is going to be, and you can do this two ways now, right? You could use E equals hc over lambda and go back to the original, which I think is what I'm going to do. You could use E equals h nu and plug this guy in for nu. Doesn't matter at this point. Either one is fine. I'm going to do it this way, 6.626 times 10 to the minus 34 joule seconds, 3.00 times 10 to the 8th meters per second. Wavelength is 0.0950 meters. Meters cancel, seconds cancel, you're left in joules. Joules is the unit of energy. Hooray, 6.626 times 3 divided by 0.095. So it's going to be 2.09, and then I got a 34 and an 8. That's going to be minus 26, minus 24. 10 to the minus 24 joules. Okay. All right. So there's just a couple of equations you have to know. You have to think about your units a little bit. Otherwise, it's relatively straightforward in terms of plugging in and chugging. But it is important that you do lots of practice on these just to get comfortable with it, get comfortable with the equations, know what the constants are, get comfortable with your calculator in particular. And yeah, if you have questions, please leave a comment or get in touch. Thanks, everybody.